When I came to this room this morning, I was like, nobody's going to ever find this room and there will be no people there. Um, Apparently, some of you made it quite hard after lunch. Yes. My name is Michael. I'm a developer working for ThoughtWorks in Hamburg, Germany. And it's actually my first time in Poland. And so far, I can tell the beer is good, the weather is so-so, and the coffee is crap. Prove me I'm wrong. There's a reason why I'm giving this talk. So when people ask me, what does your company do? I say, we build software. And then they say, well, what kind of software are you building? And I was like, yeah, basically everything. We can build your website, we can build your apps, we can build your backend service. But hey, wait, actually, we are not really good at hardware. So embedded system, this is really not our thing. And I had the feeling that the hardware people and the software people are actually separate worlds, because I hear this from everyone. Either you're building hardware or you don't. And I don't really like this, and I think in the near future, we will work much more closely together. Second reason why I'm giving this talk, this Internet of Things thingy, right? It's so annoying. It's everywhere, right? I looked at the IBM website, and they said I could do Internet of Things right away with the website. So I took out my phone, I scanned the QR code, then something was on my phone. I don't know what it was. And there were like numbers going up and down, and on the website there was nothing. So I was like, oh yeah, this is Internet of Things. Let's be a bit more specific and a bit more detailed than that. Third reason, I spent 1 year of my life with this project, and 1 year is long, and it's exhausting sometimes. So I kind of now want to draw a summary and share with you the things I learned on this project. This talk will be structured. First of all, we said Agile software development meets connected devices. I want to talk very briefly what Agile means. I want to give you an overview of the project I was working on. And then we will look at different topics. Prototypes, feature flow, testing, environments, and security. And for each topic I ask, what would be the traditional Agile approach to this topic? What were the challenges we faced on this specific project when we tried to adopt those methodologies? And how do we adopt them? And after that, we're going to sum up and finally come to the lessons learned. So let's talk about Agile. I don't know about Poland, but at least in Germany, Scrum and Agile is exactly the same thing. So a client comes up to you and says, do you work in an Agile way? And you say, yes, we do. So where did you get your Scrum Master certification from? And then you're saying, like, I don't have one. And then they look really weird at you. So this is not what I mean by Agile. By Agile, I mean lightweight, fast, and flexible. And I guess that's somewhat more closer to the original idea of the Agile Manifesto. And I want to highlight a few things. So the most important things we worry about is working software, right? Nobody cares about black boxes of architecture drawn on a whiteboard, but everybody cares about release software. And we achieve this by doing small, continuous improvement. Release something early, find out it does not work, then change it. Second thing, fast feedback. If you want to release early and often, right, you need fast feedback. So basically the key to that is to automate everything. Automate your tests, automate your provisioning, automate everything. And the third thing is respond to change. And this is quite my favorite bit, because you can easily achieve that with building the simplest, most stupid solution you can ever think of. Because then you don't produce waste, right? So the client came to us and said, we have this great project for you. We will build a coffee machine. And it won't be just a coffee machine. There will be black liquid of happiness coming out of this machine. It will be great. And it's not only a machine, right? It's a smart machine. So it can produce the coffee exactly the way you want, and it can adjust to water hardness and whatever you can think of. And it will be a connected coffee machine. So people can, configure their machine with their phones. So it's a connected product. And it's not only a connected product, but it will actually be a product system. So there will be a backend, which is this thingy right there, that has attached all these services, and from your phone and with your machine, you can do so much stuff. And by the way, you're not going to build the hardware. We have somebody else that actually knows how to build coffee machines. But you will build the app and the backend services. We're like, yeah, that's great. Sounds good. So let's get started. And pretty soon we faced some challenges. And I want to highlight a few of our most challenging bits. So first we had the meeting with the guys from the machine that actually built the machine. And we were like, okay, let's get going. Let's define some endpoints and some JSON structures, and let's get going. And they looked at us blank, and they laughed and like, oh, JSON, HTTP, that's just fancy candy for the internet kiddies. Let's do something binary. Let's do something more on a UDP level. And as much as they were shocked, we were shocked afterwards. So all of a sudden, we realized that resources suddenly matter again, which was pretty new to me because I was used to just put in another Amazon instance and then it will work, right? Second thing is to actually get things connected. Because if you get this coffee machine and you unbox it and you put it onto your kitchen table, guess what? It doesn't know your SSID and it doesn't know your Wi-Fi password. And by the way, it doesn't have a keyboard, so you can type it in. And actually the screen is about that big. So this was quite challenging. And the next thing was, if you think about connected devices, actually most of the time you spend about what happens if they are not connected. So we just heard from Johannes a talk right before lunch that's completely about offline. And we had all this. When people say everything is connected, well, what we have to worry about is actually everything is offline. And every single story you build and every single feature you want to define, you have to think about, what happens if it's offline and then comes online again with a high latency and then the network, so this was challenging. The last bit, the last challenge was user flows across different devices. So I'm making this up right now, but the real scenarios are pretty much like that. So user brews the coffee. The coffee says, I need cleaning. So it sends to the backend, I need cleaning. The backend sends then to the app via push notification, you should really clean your coffee machine. Well, the user reads that and then from his phone sends to the machine, start cleaning now. And then the machine has a green light and it says, I'm clean now. Your coffee will taste good. I never knew how to build and test and define this, so this was quite complicated. But nevertheless, we were like, okay, let's get going. And then give us your small machine, and then we just start building it. Fun fact, there is no machine. It will be there maybe in a year or in half a year, but you have to start without a machine. So those were the key challenges to this project. So because there was no machine, let's talk about prototypes. So when I say prototype, I mean some early model or version you use to verify your assumptions, because we make so many assumptions and the best thing you can do is build something and try it out. And when we think about, let's say, standard agile development, one of the things we do very early is we create some dummies. So you start scribbling something around on a paper that looks somewhat like a website, you show it to your colleague and your colleague says, no, this is crap. And then you scribble something again, and they say, yeah, let's go with that. And then you use tools. I don't know the tools. I'm not an experienced designer. And you come up with those wireframes, and then you can actually, start to get a layout in something. And then you actually build something you can click, and you give it to real users, and they just click on it, and then you can see if it's working or not. And then we usually start with something we call iteration 0. So we really now kick off to build something. And the first thing we build is a hello world. On your browser, hello, I can connect to the database. Hello, I was deployed automatically. Hello, everything works together. So at least you plumb together all the bits and pieces of your project. Well, and then you start building an alpha, right? Real core functionality, and even though it's not perfect, even though it doesn't have Facebook integration, right, you can already put it in front of maybe some internal users, you can harden your deployment process and everything, and then you can actually focus on your beta version where you want to put it in front of real users, but it's not perfect, right? Things will change, but you can still try out stuff. And then you do the release, and then it's finally live. For hardware, this works a bit differently. And it's a shame that I wasn't there on this project yet. They started with dummies as well. So they 3D printed a coffee machine. They played around with touch screens and glued them onto this 3D printed machine. There was a Raspberry Pi inside, faking whatever the machine does. And I heard the first one actually had loudspeakers to make coffee sounds, so they could do some user testing. I wish I had been there, so that was quite fun. But then we needed to get going, right? We needed to really implement our app and the back end. And yeah, there was nothing. So we started by building a coffee machine service. So we took Node, and it responded to localhost 3000, and you could actually call it and respond it, right? And we start to implement features the machine might have in some future, and you can at least start developing your backend and the app against that. Obviously, this was very, very far from reality because, well, this software doesn't use Wi-Fi and it's pretty fast on your machine. And when we started to get things connected, we actually wanted to test this Wi-Fi setup process. Well, then all of a sudden, a local service on your machine is not enough. So we took Beagle boards. I don't know if you know, this is basically like a fat Raspberry Pi, and we ran the software that was before running on our local machine. We ran it all those little devices, and they could spin up hotspots, and then you can, configure it, and then they would tear down the Wi-Fi adapter and spin up in your Wi-Fi, and so you can actually try all the things. This was quite tedious, but really helping us a lot. And then we had the box. So the hardware guys sent us the box. And the box was basically like a coffee machine that doesn't brew coffee. So it had all the user interfaces, it had a display, it had all the controls, and it was this firmware that was actually running on the real thing was also running on that one, but it didn't brew coffee. But this was really helping a lot because we could have much more realistic testing, because this one was actually not responding fast. This was actually failing, or it stopped working at all at some point. So this got much more realistic. And what was interesting for us when we worked with this prototype, you could not just go and like, oh, there's something wrong. Let me just check in the logs. And you would just tail on some machine and read what's going on, because the machine didn't log anything. And then we had finally the real prototype. So a real coffee machine that could make coffee. Well, actually, the first prototype we got could make clear water stink, but it got a lot better. So yes, you can do prototyping with hardware. It's a lot different, and so let's look a bit at the differences. Well, if you have a dummy, you can do that in minutes or in hours, right? And basically with alpha and beta versions, with every single commit you do, you can build a new version out of that. With a 3D printed fake machine, you can't really do this, right? It takes weeks and months to build something like that, especially when we come over to the box. That took forever. And if you look at what is real and what is fake in the prototypes, then you realize in the traditional agile development, well, you have some fake software, you have something you throw away, but from very, very early on, you'd actually start to build the real software, and you throw stuff out and you put stuff in, but from very early on, it's the real thing. For us, it was the exact opposite way around. We were faking everything we didn't have until very, very late, so that, and we were very late, so that we could actually use the real hardware. This also then meant that the purposes of the prototypes were quite different. So on the top, you actually implement real features, and you test those features, and this is good, right? For us, it was more a way around to maybe define the interfaces and define the data structures and get everything going with that, but it was never the real thing. Feature flow. When you start a project, it's a bit bumpy, right? So you have this wall, and then all the cards come up, and the first stories take forever, and all the developers say, well, the database is not set up yet, and we have problems with Amazon. But after, I don't know, 1 or 2 iterations, you start to get into this flow, right? And you build one feature after another, and everything is working nicely, and everything is improving. And you really start with a very, very core functionality first, and then you build stuff around it. And then there comes the Facebook integration, and then you build even more stuff around it. So this is what Agile is about, right? Having a good flow so you can adjust every moment. And even if you're completely wrong, you throw away maybe 1 iteration, right? You just revert. On this project, it didn't feel like that at all. We tried really hard, but it felt more like this. We defined a bunch of features, gave them over to the machine guys, and they were like, no, this doesn't work at all. So we were going back and forth, and then we were implementing stuff, and it didn't work at all because the machine was not doing this. And then it was doing this, and we found out the structures changed and everything. So this was really, really bumpy. Also, there was no machine that would brew coffee, which seems to be kind of the core functionality of a coffee machine. So instead, we were playing first how to set the water hardness on the machine. Water hardness for what if you can't brew any coffee, right? So it was more outside in development. And this is quite dangerous because you tend to lose sometimes the overall view on what you're actually doing. And you can't really imagine the user that interacts with all the different devices. Well, something is working here, something is working there. You don't have the whole flow you can actually play through and verify your assumptions. Also, you start developing something, and no, it's not really working. And then the next machine firmware version comes in. Oh, we have to adjust this and that. So all this upfront work actually made us redesign, rebuild, and redesign actually quite a few things. And what was very clear in this iteration, that software always wraps around the hardware. The hardware is the stuff that you can't really change at some point, so you have to build your software around this. Favorite part, testing. Testing seems to be the core part of Agile, right? Because it actually allows you to build simple solutions. It's very helpful for incremental, continuous development and refactoring. And the test automation gives you fast feedback. And no talk about Agile is complete without the testing pyramid. So you always want to build lots of unit tests, corner cases, tons of them that run really, really fast. But when you hit the database or you hit a file system, then you want to have more integration tests because they are much slower. And you want to have very, very few functional tests that actually are just testing if you plumb the things together correctly. For us, this could work quite a bit, right? On a backend, I can do this. We know how to do this. It's business as usual. Honestly, to me, for an iOS app, functional test was a bit of a pain and a bit new, but it works. For the machine, well, I don't know how they did it, but it's clearly doable, right? C code, you can test that as well. But this does not test the real user interaction. This does not test the real user flow. It just tests bits and pieces of your systems. And when we wanted to build a new feature on the app, well, there was nothing, that would support this feature. Or like, how can we automatically test that if we get the real thing, that this is actually doing what we want it to do? So we came up with a thing that's quite common when you work in separate teams. We wrote contract tests. So we wanted a new feature, and the first thing we do, we write a contract test. If there is a machine, it should behave like that. And then we had our fake services and fake machines, and we would implement this feature on the fake machine, and then the contract test would pass. And then we actually started to build the feature on the app or in the backend. So we defined what it should do, We made the machine do it, at least a fake machine, and then we actually start using it. And when then a firmware update came, we could run those contract tests. And at least we could say, it was not the fast feedback you want, because it was in weeks or months, right, after you get a new firmware feedback. But at least in an automatic way, you can tell if the machine does what you expect it to do. And this was really, really helpful for us. Because then we could then really, at least hope that the app would do exactly what the machine is supposed to do. Sounds good? But unfortunately, this machine has buttons, and somebody will press these buttons. And since some of the workflows involved user interactions, we could not really think of a way how to automate this, right? I know, I've seen those robot fingers that type on a tablet. We didn't go for this approach. I went to different testers and I was like, how can I test physical user interactions? And they were like, oh, this is easy. You can't. You have to test it manually. This is what we are doing. We didn't go with this approach. So we still wrote functional tests, and we said, well, let's just assume there is a user. And then we just say, user, press this brew button. And for our fake machine, we had an implementation of this interface, and it would call a specific URL on the machine that is not part of the real API. It's just, to help us around. So on the fake machine, we could just pretend that the button was pressed. Well, what do you do with a real user then? Well, you put a real user in front of it, and then you show a message. Please press brew. And this felt really weird, because all of a sudden, these automatic tests turned, if you run it against a real machine, into, let's call it, guided manual testing. So at least you can make sure that you run all the tests, and you run exactly the tests you ran in an automatic way. But then somebody has to sit in front of it, and then now go to the machine and press boot. So you go over and you click, and then you go back, and then you click, go on. Now go to the machine and type in what's written on the screen. And it sounds really stupid, but it worked actually pretty well. When it came to the user journeys, I highlighted in the beginning how the user journeys work across all the different components. If you have real end-to-end tests, this is really pain to set this up. Your backend should behave like that, and this data should be there. The machine should be in that state, and if you do click this button then on your app, then stuff should happen. And honestly, we could not handle it. It was just too much complexity, and the tests were just so brittle and so hard to set up. So we cut the corner a bit. And we actually said, okay, we split the user journey so that they would involve only 2 of those 3 components. Because if you cut complexity in half, you actually gain a lot from it. So this was not 100% end-to-end, but this was our way around it. And now we have those contract tests, we have the fake user interactions and the guided manual tests, and we have those partial user journeys, and that actually allowed us to chop up this beast of user flows into eatable chunks so that we can not do fully automated testing, but as much as we can. We didn't have real end-to-end all the way, but at least as much as we can. Oh, this is the good part, because I'm now 36 years old, so I'm old, and now I can talk about the old days. So when I started development, when we built environments, we actually had servers under our desk. So the first company I worked for was in the living room of my boss, and we could put our feet on the servers that were running in production, and if there was a lot of traffic, our feet would get warm. Obviously, this was not very scalable. So then we started to move into a real data center. So we just bought the machines, drove over to the data center, and then we shoved in those machines, and hopefully they were working. But now, 2015, you don't even do that anymore. Actually, you don't even know where the servers are, right? You just get out a credit card and you throw all the money into Amazon, but at least you have the servers now within seconds. Also, when it comes to configuring stuff, in the beginning, I was literally doing apt-get everywhere by hand until I was so tired of it and wrote this little setup.sh script. so I don't have to type all the commands again and again. But now we use Puppet, Chef, or I prefer Ansible now because it's so much easier and I at least understand it. But we got all those nice tools. So we can now spin up environments within, let's say, minutes. And you need different environments for your project, right? The developer needs an environment on his local box to try out stuff. You probably need testing environments, and you at least want to have one production environment. And most software projects I work for, you can run everything on your machine. A database, a backend, maybe some client that is running there. This can all run either on a local VM or really on the local machine. When you go into more production-like systems, you probably want to have separate machines for all the different components, but you just spin them up and then install them. For this project, for a dev machine, this was actually quite similar because we can run a backend on a local machine. You can run let's say, iPhone simulator on your local machine, and I mentioned those fake services we had. You can run that as well. So you can at least start developing and try out stuff, but obviously this is very, very far from the real thing. So when we built test environments, we deployed the backend and the database to the cloud, and we wanted a real phone, so you have to set up some machine in your office that connects to a phone so you can actually automatically deploy to that phone. And then we needed those beagle bones. So all over the table there were these little boxes and they were blinking. And we needed Wi-Fi's for that as well, right? And then you want to have a second machine that's not configured, because you want to have one that's configured and one that is not, and you need a separate Wi-Fi for that. And then you finally get a real machine, and guess what? You want to have a separate Wi-Fi for that as well. So actually we ended up with 5 or 6 Wi-Fi's in our office. Our sysadmin was really mad at us because we came every day, can you configure this and can you configure that? This is tedious and this is actually quite annoying, but it was the best we could think of. And the interesting bit with this situation is that when you build hardware, stuff is actually moving from the cloud back to the desk. And all of a sudden everything that was automatic becomes more manual again. And again, what took minutes before now takes hours. Security. Security is important. And when I come to a team and I ask, what is the agile approach to security? People always first they look blank and then they ramble, yeah, we are not really the experts on that. There will be a separate company that does an audit and then they produce a PDF. And I struggled with that as well when I prepared this talk. I was like, what is the agile approach to security? And I try to come up with some of the things. Cross-functional teams, yes. It definitely helps that the ops guy is sitting together with the developer and is sitting together with a business analyst. So putting everyone in front of one table really helps. Automatic testing helps. Well, it really depends on the test you're writing, but if you rerun the test all the time, at least what was working before should now be working again, or it will just at least fail. And what definitely helps is automatic provisioning. I never configured a server manually without any mistakes. But if I let Ansible do this, it will really happen. So yes, we did all this, we tried all this for the stuff, but this was clearly not enough because the situation was so different. There's a machine in the kitchen of the users and they have all the time they want. They're in their local Wi-Fi, they can do everything they want. They can take a screwdriver and open it. And so we're like, yeah, we need something else. So we brought in a bunch of other guys from another team and we ran a threat modeling workshop. And I'm not going into details into that because you can have a whole talk about threat modeling. But we really sat down very early in the project and started to think about security boundaries and scenarios that actually matter to us and that don't matter to us. And what I want to share with you is the 3 scenarios we always describe, which is not the entire thing of the security system, but at least quite interesting. Scenario 1. You break your own machine because you have all the time. You can take a screwdriver, you do a Wireshark in your network, we don't actually care. If you break your own machine, well, maybe you have a nice YouTube video where you know, that you publish, where you try to configure something and it didn't work. But if you really take a screwdriver and open it, we don't care. And this was interesting because all the if, when, like all of them were gone regarding this scenario. We don't care. But also this means everything that is on the machine is not safe. You just assume that if it's on the machine, somebody will know it, which is a good assumption to make. Scenario 2, you break somebody else's machine. Well, this is not nice, and we put some effort into it to avoid those scenarios. But on the other hand, you are in somebody person's house, maybe even connected to the Wi-Fi, and they probably can't even stand in front of the machine. So we worried about this, but we were not panicking about it. And what we use for that a lot of the times is actually to use physical interaction. Because if you do something on the machine that's very, very critical and you have to confirm it by pressing a button, you can at least assume that this person is standing in front of the real machine. And then we had scenario 3. Somebody can break all the machines. Because, for example, if you update your machine and somebody manages to put a mal firmware into the machine and into every machine, then all of a sudden you have 20,000 bricks. And it's not like you can, you know, just put an update onto the server and then restart. No, they're there. They're dead, right? They're in the kitchens. People have to take them and put them back to the store. So we worried a lot about this, and this was quite interesting. We actually used a lot of things we know from software development now for the hardware people. So, for example, asynchronous encryption. Before you install a firmware update, you better verify that this is a good update. And this was so new to them and so out of this world, it was really, really fun to see. So let's recap. For the prototypes, we used 3D prints, we had the fake machine, we had this box thingy. That went, I don't know, it was much slower than we are used to, right? But at least it was getting the job done. So I'm giving ourselves 4 out of 5 Scrum Master certificates for that. Regarding the feature flow, we really did lots of upfront design. We had to rework. We were very late with the core functionality. I must say, well, on the next project, I will just put much more focus on that one, so just 1 Scrum Master certification. Regarding the testing bit, we had those guided manual tests, we had the contract tests, the partial user flows. This was, at least to me, all very, very new stuff, and I'm sure the next project I will learn a lot and reuse that a lot. So 5 out of 5 Scrum Master certificates for that. The environment, well, we tried hard. But if stuff is on your desk and if you really have to go to the shop to buy a new phone, to have a new environment that has a real phone, I don't know if there's much about you can do. If you have ideas, come to me. So 2 out of 5. Regarding the security, I'm not a judge here because this thing is not out. But at least I can say that on this project we worried much more often and a lot earlier about security. We did a much deeper analysis on everything than on all the projects I've worked so far. So we get 3 out of 5 for that. Some of the things I want to sum up. So if I would start a project tomorrow, these are the lessons learned, and I would do either again or would do them differently. But this is a very, very personal opinion, and if you would, I don't know, ask somebody else from my team, they would probably have a different one. But here are the top 5. Resources suddenly matter again, and hardware is hard to change, so the software has to build around it. This was really annoying at some point. For example, if the machine says, "Oh yeah, we can do JSON," but you can't use arrays. Why? Because, you know, too much memory when we parse it. Okay, so just live with it. It's not that hard, right? But these are the things that will happen again. Offline complexity and those user flows means so much more analysis up front. And even though the story says, oh, by the way, when it's offline, it should show a hint, most of the time, this will definitely be not enough. Don't reinvent the wheel when getting things connected. So in this case, We were very specific about the hardware requirements, so we basically had to build a setup flow ourselves. But there are things out like spark.io that basically do that for you. So if you can afford it onto your machine, then use stuff that does that for you. I'm sure in 10 years nobody will ever build a Wi-Fi setup flow again. Automate more than you first think is possible, because it's not 100%, because it's not exactly the way you're used to it from software development, doesn't mean you shouldn't try at all. It's actually the other way around. It's actually the things where you have methodologies that you can apply, and you just need to push much more forward to that. Co-locate with the hardware people. So we had meetings and we visited them, but the next project with hardware, I'm going to sit on the mechanics lab, because this will solve so many problems we had during the whole time. Thank you.